Hello and welcome to Mr. Tompkins Ed Tech. This series of videos provides work solutions for the GCSE Maths topic test produced by AQA. This video is Standard Form. Whilst these topic tests make excellent exam preparation and revision material, regardless of which exam board you're sitting, they are particularly useful for students studying for AQA as they are prepared by the same team who will be writing your papers in the summer. They will work best if you try and answer the questions yourself before watching the video. The topic test papers can be downloaded from this address, which I've also linked in the description below. They'll require a teacher account to access, so either ask your maths teacher to download and share them with you, or alternatively you can try pausing the video and attempting the question first before pressing play again to listen to my solutions. Check this playlist for all the other topics I've covered. I'm busy recording all of these topic tests, so if the particular topic you're looking for isn't there yet, why not drop me a comment below with your request and subscribe to my channel to receive notification of future uploads. If there is anything you don't understand, please ask in the comments. Make sure you mention the question number and try to be as specific as possible. I try to answer all questions promptly, especially around exam times. If you found the video useful, please do hit the like button, as this really helps me out. You might also like to check out my exam paper walkthroughs covering all the recent papers and practice papers from AQA. Just click on the card appearing at the top of the screen now. Okay, let's get started. Question 1. Here are 5 numbers. Work out the difference between the largest and smallest numbers, giving your answer in standard form. Okay, now the first issue we've got here is we've got two different types of numbers here. We've got numbers written in standard form, and we've got numbers that are not written in standard form, which makes it a bit hard to compare. So because 3 out of 5 are already in standard form and my answer needs to be in standard form, I'm going to convert the 2 that aren't into standard form rather than the other way around. So let's have a look at the first one first, 47,000. Now a standard form is going to be a number between 1 and 10. So changing those and keeping the digits but rewriting it as a number between 1 and 10, I get 4.7. And that's going to be times 10 to the power of what? Well, the decimal point started here and it's moved 1, 2, 3, 4 jumps. So it's going to be 4.7 times 10 to the power of 4. Similarly, 125 I can rewrite as 1.25. This time the power of 10 is going to be 1, 2, 3, 4, 5. It's going to be 10 to the power of 5. Okay, so I've got 5 numbers now in standard form. Now to find the smallest and the largest, we need to look at the magnitude of the numbers. So the magnitude is given by this power of 10. 10 to the power of 3 or 4 or 5. So I'm going to pick the number with the smallest power of 10 as my smallest number, and that's this one here, isn't it? 5 times 10 to the 3. So that's going to be my smallest. So let's just write that down. Smallest is 5 times 10 to the 3. The largest is going to be the number with the largest exponent. I've got 2 with 10 to the power of 5. Look, this one and this one. So if these two powers are the same, then the next thing to compare is the numerical part. It's the mantissa, we call it. So we find the number with the largest mantissa. So 2.8 is bigger than 1.25. So 2.8 times 10 to the 5 is the biggest number. So the biggest is, what is it? So it's 2.8 times 10 to the 5. Now what we want to do is now work out the difference between them. So working out the difference between numbers is largest take away smallest, isn't it? So difference is the largest number, 2.8 times 10 to the 5, subtract 5 times 10 to the 3. Okay, so when subtracting numbers in standard form, we want to try and make these numbers at the end the same power, so we can subtract the mantissas from each other. Now at the moment I've got 10 to the 5 and 10 to the 3. So I'm going to rewrite this first one as a number times 10 to the 3. So the difference between 10 to 3 and 10 to 5 is 10 to the 2. So if I then multiply 2.8 through by 10 to the 2, or 100, I'm going to get 280. Another way of thinking about it is I've reduced the power by 2, so I'm going to move the decimal point 2 places to the right to compensate. Okay, so I've got 200 times 10 to the 3, subtract 5 times 10 to the 3. Now these two numbers are in the same, have the same exponent, 10 to the power 3. I can subtract the number part, or the mantissa part it's called, these numbers here. So 280 subtract 5 is 275. Again, that's still times 10 to the power 3, but that number isn't in standard form, so I now need to rejig it back into standard form by moving the decimal point 2 jumps back. So that's going to be, my final answer is 2.75 times 10 to the 5, like that. Question 2. Work out 5.9 times 10 to the 7 divided by 2.3 times 10 to the 4. Give your answer in standard form to two significant figures. So I'm going to rewrite this as a quotient because it's a bit easy to see what's going on. So 5.9 times 10 to the 7 divided by 2.3 times 10 to the 4. Now first off, I'm going to divide the exponent parts by each other. So 10 to the 7 divided by 10 to the 4. That's going to give me 10 to the power of 3. 7 subtract 4 is 3. And I've got 5.9 divided by 2.3. Let's just pull up a calculator to work out what that is. 5.9 divided by 2.3 gives me 2.5652, etc. I'm going to round off then to two significant figures, which is 2.6 times 10 to the 3. Question 3. Solve x over 0.02 is equal to 3.1 times 10 to the minus 4. Okay, so I've got an equation in here in x that we need to solve. Now, if I had x over a is equal to b, then the first thing I would do is cross multiply that a up there, and that would get me x is equal to ab. And I'd work out what a times b was, and that would give me an answer to x. So I'm going to do the same thing here. I've got 0.02 at the bottom here. I'm going to move it up here. Change, well, it's called cross multiplying, so it's divide on one side, becomes times on the other. But as I move it over, I'm just going to rewrite it in standard form so it matches the form of the other part of the number. So x is equal to 3.1 times 10 to the minus 4. That was a bit that was already there. And now I'm going to multiply it through by 0.02. 0.02 in standard form, it's going to be 2 times 10 to the minus 2, isn't it? Okay, so I've got 3.1 times 10 to the minus 4 times 2 times 10 to the minus 2. Now when you've got numbers in standard form and you're multiplying them, all you need to do is multiply the mantissa parts, the number parts like that, and then we multiply the exponents, those parts there, or the powers of 10. Okay, so let's just do that then. 3.1 times 2, well that's just 6.2. And 10 to the minus 4 times 10 to the minus 2, we've got numbers with the same base, so we simply add the indices. Negative 4 plus negative 2 is negative 6. So my answer is 6.2 times 10 to the negative 6. Question 4. In total, tourists visiting a country spent 5.2 times 10 to the 8 pounds. On average, each tourist spends 645 pounds. How many tourists visited the country? Give your answer in standard form to an appropriate degree of accuracy. Okay, so this number up here is my total spend, and each person spent on average of 645 pounds. If I divide one by the other, I'll be able to work out on average how many people visited the country. So on average, so number of tourists is going to be 5.2 times 10 to the 8 divided by 645. I'm going to rewrite that in standard form. 6.45 times 10 to the what? Decimal point is moved 2 jumps, so it's times 10 to the 2. Okay, so dividing the exponent part is very easy. 10 to the 8 divided by 10 to the 2 is 10 to the power of 6. And then the mantissa part, what is 5.2 divided by 6.45? I'm just going to type that into the calculator. 5.2 divide by 6.45. Now that comes out to be 0.8062. It says to an appropriate degree of accuracy here. Now, what would an appropriate degree of accuracy be? Well, my total spend is given to 2 significant figures, and my number of tourists is given to 3 significant figures. So basically, I can't really give any more than 2 significant figures as my answer. And that's how the number has been rounded off in the first place. So rounding off 0.8062 to 2 significant figures, I'm going to get 0.81. Okay. Now that number isn't quite in standard form. It's 0.81. The number part needs to be a number between 1 and 10. So rewrite that as 8.1. But then I need to adjust my exponent by 1 as well. So it's going to be 8.1 times 10 to the power of 5. Question 5. Here are the probabilities of 2 independent events. Event A is 2.7 times 10 to the minus 2, and event B is 3.4 times 10 to the minus 4. This is how many times more likely is event A than event B. In other words, how many times bigger is A compared to B. Now, if we want to work out how many times bigger one number is compared to the other, we just need to divide them, don't we? So what I need then is to work out what 2.7 times 10 to the minus 2 divided by 3.4 times 10 to the minus 4 is. Okay, now again, starting with the exponent part, 10 to the minus 2 divided by 10 to the minus 4. Just take care with adding and subtracting positive and negative numbers here. If you're at negative 2 on the number line and you're subtracting negative 4, that means you're at minus 2 and you're adding 4, which takes you to 2. So the power is 10 to the 2. The mantissa part I can get by by dividing 2.7 by 3.4. So I'm just going to tap that into my calculator. 2.7 divided by 3.4. That gives me 0.794. It doesn't ask me to give it to a particular degree of accuracy, so I think I'm going to stick with the 2 significant figures that both of the answers or both of event A and event B are given to. So I'm going to write that as 0.79 times 10 to the 2. Now that's not quite in standard form, is it? So actually it doesn't even ask us to put the answer in standard form. So what is 0.79 times 100? It's going to be 79 times, isn't it? So it's 79 times more likely that event A happens compared to event B. 5b, work out the probability of only one of the events happening. Give your answer to 3 significant figures. Now, we've got 2 events, A and B. So the probability of exactly one happening out of A and B is the probability of event A happening and event B not happening plus the probability of event A not happening and event B happening. Okay, so that's what we need to work out. So we know the probability of A and B, and the probability of not A and not B is going to be 1 minus those amounts, isn't it? So up here we've got the probabilities that those 2 events happen. So then the probability that they don't happen is going to be 1 minus that, isn't it? That's not very nice. I think I'm going to convert both numbers into normal numbers first, and then work out what their 1 minus those numbers are. So the probability of them happening then, 2.7 times 10 to the minus 2 is 0.027. So that's the probability that it happens. So the probability that it doesn't happen then is going to be 0.9, what's that, 973? So that's the probability of it not happening, because the two things add up to 1, don't they? And then 3.4 times 10 to the minus 4 is going to be 0.00034. That's the probability that it happens. So the probability that it doesn't happen is going to be 1 minus that. So that's going to be 0.99966, isn't it? Okay, I might want to just double check that on the calculator, but I think that's right. So then coming back to our maths down here, the probability of A not B is going to be the probability of A and not B, that one there, 0.027 times 0.99966. So that's going to be what was it again? 0.027 times 0.99966 plus the probability of not A. Not A was 0.00034. 0.00034 times the probability of B. So that's the probability of B times the probability of not A, which is 0.973. 0.973. So I'm going to get a calculator out to do that. .027 times 0.99966 plus 0.00034 times 0.973. I make that 0.02732, and I've been asked to give this to 3 significant figures, so that's going to be 0.0273. Question 6. In the body, the ratio of the number of red blood cells to the total of all cells is 5 to 9. It is estimated that there are 3.72 times 10 to the 13 cells in total. Work out the number of red blood cells. Give your answer in standard form to an appropriate degree of accuracy. Okay, so we've been given the ratio of red blood cells to total cells. So red blood cells to all cells is in the ratio of 5 to 9. And we're told that there are 3.72 times 10 to the 13 cells altogether. So how many red blood cells does that make then? Okay, so we can go via what we call the unitary method, which is going via 1. So you take your number, divide it by 9, and then times by 3.72 times 10 to the 13. Okay, so that's what I need to do on the other side as well. So I'm going to take 5, divide it by 9, and then times it by 3.72 times 10 to the 13. So the number, and that's going to give me the number of red blood cells. So that's going to be equal to 5 divided by 9, and then times by 3.72 times 10 to the 13. So I think this is a calculator question, so I'm just going to work it out on the calculator. I'm going to do the numerical part first, and leave the 10 to the 13 until last. So what is 5 divided by 9 and then times by 3.72? Now that's giving me 2.0666. Well, it's reoccurring, isn't it? So rounding that off to an appropriate degree of accuracy. Now, this number of cells was given to 3 significant figures, so 3 significant figures would be an appropriate degree of accuracy, or fewer, maybe 2 significant figures. I think I'm going to go for 3. So I'm going to write down 2.07. 2.07, that's the mantissa part, and then I'm just going to leave the times 10 to the 13 on the end. 2.07 times 10 to the 13. Well, that's that. I hope you found the video useful. If you did, please hit the like button and consider subscribing to my channel. Also, check out the playlist on the right for more topic tests, or the one down below for past papers. See you again next time.